Hello and welcome to Math Matters. I'm Ms. Granados and today we're going to be learning to compute fractions. In today's lesson, we'll be solving a practical problem involving fractions and mixed numbers and then sharing our thinking about how we solved it. We'll look at the connections and differences between two different strategies. At the end of the lesson, you'll know you've met today's learning intention if you are able to meet the following success criteria. I can solve multi-step practical problems with fractions. I can compare and contrast other people's strategies. You'll need some paper and something to write with, so go ahead and gather your supplies. Today's number sense routine is a splat. What number is represented in this model? Let's count the blue circles first. Since the whole circle is shaded in, I'm going to count by whole numbers. 1, 2, 3. Now the other circles are split into 3 equal parts, and one of those parts is shaded in green. I can count those by 1/3. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, which is the same as 2 wholes. So all 6 green parts make up 6/3, or 2 wholes. When I add the 3 wholes to the 6/3, I get 5. Okay. Splat. What is the total under the splat? Well, what do we know? How many can we still see? Yeah, let's count the whole numbers first and then the fraction. 1, 2, 2 and 1/3. We can see 2 and 1/3 and we know there are 5 total, so how many are under the splat? Take about a minute to figure out how many are under the splat. Use your communicator skills to explain or justify your answer, either by explaining it to someone near you or by writing it down. If you know how many are under there, can you think of a different way to think of the splat? Of what we started with, 3 whole circles and 6/3. Then you might have thought about taking away the circles that we could still see. We can then count how much is left. 1, 1 and 1/3, 1 and 2/3, 1 and 3/3, which is the same as 2, 2 and 1/3, 2 and 2/3. So 2 and 2/3 might be what's under the splat. How could we write a number sentence for this strategy? Well, we started with 5 and took away the parts we could see, 2 and 1/3. So the equation could be 5 minus 2 and 1/3 equals 2 and 2/3. What's another strategy? Maybe you started with what we could see, 2 and 1/3, and then counted up. 2 and 2/3, 2 and 3/3, or 3, 3 and 1/3, 3 and 2/3, 3 and 3/3, which is the same as 4, and 5. Once we get to 5, we'd need to figure out how many we added. So to figure out how many more we added, we can start counting the whole circles first and then add the fractional parts. 1, 1 and 1/3, 1 and 2/3, 1 and 3/3, which is the same as 2 wholes, 2 and 1/3, 2 and 2/3. So we added 2 and 2/3 more to get to 5. What equation represents this strategy? 2 and 1/3 plus 2 and 2/3 equals 5. Let's see if we're correct. Let's look under the splat to see the total. 1, then 3/3 makes 2, and then 2 more thirds makes 2 2/3. Yeah, we were correct. Let's look at this story problem. Kylie made some fudge. She made some chocolate fudge and some vanilla fudge. The rest of the fudge was caramel. What are you picturing in your mind as we read this story? Besides wanting to eat some fudge right now, we know that Kylie made some fudge and that the flavors of the fudge she did make included chocolate, vanilla, and caramel. Kylie made 4 2/5 pounds of fudge. She made some chocolate fudge and some vanilla fudge. The rest of the fudge was caramel. What changed in the problem? What did we learn from this new information? Yeah, we now know the amount of fudge that Kylie made. She made 4 2/5 pounds of fudge. Can you imagine that much fudge? Kylie made 4 2/5 pounds of fudge. She made 1 1/2 pounds of chocolate fudge and 1 3/5 pounds of vanilla fudge. The rest of the fudge was caramel. What changed in the problem? And what did we learn from this new information? Well, now we know how much chocolate fudge Kylie made and the amount of vanilla fudge she made. She made 1 1/2 pounds of chocolate fudge and 1 3/5 pounds of vanilla fudge. Did Kylie make only chocolate and vanilla fudge? How do you know? No, she didn't. She also made caramel fudge. We know because the last sentence says that the rest of the fudge she made was caramel. So we know the total amount of fudge that Kylie made, and we know the amounts of chocolate and vanilla fudge. What questions might we ask about this situation? Let's reread the problem. Kylie made 4 2/5 pounds of fudge. She made 1 1/2 pounds of chocolate fudge and 1 3/5 pounds of vanilla fudge. The rest of the fudge was caramel. How much caramel fudge did Kylie make? Let's estimate what our possible answer could be. 4 2/5 is close to 4 1/2. Since half of the denominator, 5, is 2 1/2, then 4 1/2 is the closest estimate for 4 2/5. We can leave 1 1/2 the way it is, and then 1 3/5 is pretty close to 1 1/2. So 1 1/2 and 1 1/2 is 3. That would be the chocolate fudge plus the vanilla fudge. And then if we know that Kylie made about 4 1/2 pounds of fudge, and the chocolate and vanilla fudge add up to about 3 pounds, then I could subtract 3 from 4 1/2 to estimate 1 1/2 as the number of pounds of caramel fudge. So my estimate is about 1 1/2 pounds of caramel fudge. Now it's your turn to work on the problem. How can you use pictures, numbers, and/or words to answer this question? How much caramel fudge did Kylie make? You'll have about 3 minutes to work on this problem. different student strategies. Let's hear how Jasmine solved this problem. First, she thought of the total of fudge that Kylie baked, 4 2/5 pounds, and she represented that amount with fraction tiles. She knows that 5/5 equals 1 whole, so she regrouped the whole into 5/5. Then she decided to take away 1 3/5 of the fraction tiles to represent the amount of vanilla fudge. It seemed easier than taking away 1 1/2 first. So now she's left with 2 4/5, and she knows that some regrouping will need to be done to represent the amount of chocolate fudge. 1 1/2 would mean taking away a whole and then a half. If we show half of the leftover whole, we need to think of what half of fifths would be. She decided to regroup these fifths into tenths. And she sees that halfway cut of her tenths, or 5/10. She then takes away 1 whole and 5/10, because that's the same as 1 1/2. Jasmine then counted what tiles she had left in order to represent the amount of fudge that's caramel. There's 1 whole fraction tile and 3/10 left. So 1 3/10 pounds of fudge is caramel. Did you get this answer? 1 3/10 is closest to 1 5/10, or 1 1/2, which also matches our estimate. What number sentence would you write to match Jasmine's strategy? Yep. 4 2/5 minus 1 3/5 minus 1 1/2 equals 1 3/10. So Kylie made 1 3/10 pounds of caramel fudge. Raymond had a different strategy. He decided to first add the amounts of fudge that were chocolate, 1 1/2 pounds, and vanilla, 1 3/5 pounds. In order to do this, he knew that he had to find a common denominator. Raymond knows that he can multiply any fraction by 1, which is represented as the same numerator and the same denominator, and that'll give him an equivalent fraction. So he decided to multiply both 1 1/2 and 1 3/5 by fractions that would lead to a denominator of 10. For 1 1/2, he multiplied by 5/5, which resulted in 1 5/10. And then we can see that 1 3/5 is equivalent to 1 6/10. Raymond then added the fractions, 5/10 and 6/10, and he got 11/10, which he knew was 1 1/10. He then added the whole numbers, 1 plus 1, and added on the sum of the fractions, 1 1/10, to get a total of 3/10. So now he has the total amount of chocolate and vanilla fudge made. He's not done yet. He knows he has to take the total amount of fudge, 4 2/5, and subtract 3 1/10, which is the vanilla and the chocolate that he just figured out. Raymond knew that he needed to find the common denominator between fifths and tenths. So he rewrote it vertically and multiplied 4 2/5 by 2 halves, which gave him 4 4/10. Then he subtracted 3 1/10. When subtracting, Raymond started with the whole numbers, 4 minus 3, which equaled 1, and then the fraction, 4/10 minus 1/10, which is 3/10. So the difference is 1 3/10. If we look at this strategy with fraction circles, we can start with 4 wholes and 4/10, and then subtract 3 wholes and 1/10. We can see that what's left is 1 whole and 3/10. So Raymond said that 1 3/10 pounds of the fudge that Kylie made was caramel fudge. Let's spend a little bit of time comparing Jasmine's and Raymond's strategies. What's the same about how both students solved this problem? And what might be some differences? Let's start with some of the similarities, or things that are the same about the two strategies. First, they both came up with the same answer of 1 3/10. In the fraction tiles, you see it in the amount that's left over. And in Raymond's strategy, you see it in the final computation. Another similarity is that both strategies converted to tenths. Did you notice other similarities? Let's spend some time focusing on the differences between the strategies now. Jasmine used fraction tiles to take away 1 3/5 and then 1 1/2. Raymond added the two amounts that Jasmine took away, and then after he combined those amounts, he took away the 3 1/10 from the total amount of fudge. We see these differences in the equations that we wrote to match each strategy. Notice where the answer of 1 3/10 is written in each equation, and how one is solved using only subtraction and the other one is solved using addition and then subtraction. Did you notice other differences? So today we spent time looking at and solving a splat and a fraction story problem. Did your strategy match either Jasmine's strategy or Raymond's strategy? Maybe you had a different way to think about solving the problem. The important thing is for you to understand what is happening in the story problems that you solve, and to solve them in the way that makes most sense to you and that you can explain. It doesn't matter if you use pictures, numbers, or actual manipulatives to solve the problems, as long as it's a strategy that you understand and communicate your thinking. Here's the learning intention and success criteria for today. Write down something that you learned today. Maybe it's something that you learned about solving practical problems with fractions, or maybe it was something you learned about yourself as a communicator. Is there anything you're still wondering? Maybe a question about how to use more than one operation to solve the same practical problem. If so, write that down. As I read each of the success criteria for today, use the number line to reflect on where you are in your understanding. If you feel like you understand the success criteria, then you'll rate yourself on the number line towards the right arrow. If you feel like you kind of got it, then you might be somewhere in the middle of the number line. And if you feel like you still need time to practice one of the success criteria, then you'll probably be closer to the left arrow on the number line. I can solve multi-step practical problems with fractions. I can compare and contrast other people's strategies. Remember, if you still have a question about today's learning, then you can email your teacher, ask a friend, or ask a family member. In today's episode of Math Matters, we continue to learn about fraction computation strategies in practical problems. I'm Ms. Granados. I hope you have a mathematical day and keep on counting.